particles and waves. That's where that connection comes from. And let's push that further.
Yeah.
So,
I mean, let's just drive home how weird it should be that there is any kind of connection here. So imagine I do the two-slit experiment. I cover up one of the slits. The effect completely goes away. I get a bit of spreading out of the particles, but I don't get that interference. I don't get those bands.
much as we saw with water going through a single opening.
Exactly. Much as you see with water going through the single slit, and much as you see as your classical intuition about particles. If I cover up the other slit, exactly the same result. It's only if I have both slits open at the same time the effect happens. So it seems to be for all the world as if somehow something's going through the first slit and something else is going through the other slit, and between them they're interacting to create this strange effect. And that's why it matters so much that I can do this experiment with one particle at a time. If this was just a mass of light going through, no surprise that some light's going through the left slit, some light's going through the right slit, the left-hand light, the right-hand light interferes. But I can set this stuff up so only one photon goes through every hour and a half. I still see the effect. It doesn't go down in the slightest.
Yeah, can we see that? I think we have that.
And then you might be thinking, well, maybe each individual particle breaks in half, and half the particle goes through one slit and half the particle goes through the other slit. But again, then you'd think you could look. Then you'd think you'd be seeing half-strength detections. But that's not what you see. Whenever you look, each time you send the particle through, if you look where it is, you see the particle in one place only. So trying to reconcile those two accounts of what's going on makes your mind hurt.